Hello, I am Dr. Shalini. Hello, everyone. I am Dr. Shalini Sahay, Associate Professor in the Department of Electronics and Communication Engineering from SIRT, Bhopal. Today, I am going to discuss you about the different types of signals. What is a signal? It is representation of physical quantity, that is sound, temperature, intensity, and pressure, etc., which varies with respect to time or space or independent or dependent variable. For example, voice signal, video signals, signals on telephone wires, etc. Then we will discuss about the classification of signals, the types of signals with respect to nature of the signals. First, that is continuous time signal or commonly known as analog signal. If the signal values continuously varies with respect to time, then it is called as continuous time signal or analog signal. It contains infinite set of values and it is represented as shown below. Digital signals, if the signal contains only two values, then it is called as digital signals. Discrete time signals, if the signal contains discrete set of values with respect to time, then it is called as discrete time signals. It contains finite set of values, that is sampling process converts continuous time signal into discrete time signals. Now, we'll discuss about the type of signals with respect to nature of the signals. Continuous signals, digital signals, and discrete type signals. These are the pictorial or graphical representation of the type of signals. One, that is the continuous time signal where the values continuously varies with the time. Discrete, when we sample the continuous signals in discrete time interval, then it will have the discrete time values. This is discrete time signals. When we concatenate the discrete time signals in binary numbers 0 and 1, then the signal is represented like this. It will contain the values in the form of binary numbers. Now, the representation of the discrete time signals. A discrete time signal is a function of an integer variable n. In the DS processor, the signal is represented by the discrete and coded values with a finite precision. This is the graphical representation of the discrete time signal, where we have represented in the form of x, n, and n. And on the x-axis, it represents the discrete time, and xn represents its amplitude. Now, this is the another representation of discrete time signal, which is known as the functional representation, where we have put the values of the function xn is equals to 1, for n is equals to 1 and 3, it will have the value of 4, for n is equals to 2, or otherwise it is 0 elsewhere. This is the third type of representation, that is a tabular representation, where we have represent the n, the number of discrete time, and its value at different time sequence. Now, another representation is xn, where we have given the with infinite duration signal, which means that the signal is increasing infinitely on both the sides of zero axis. Now, this is the finite duration signal, where we have taken the finite number of samples. Xn is equals to 0, -2, 1, 4, and -1, which means that the discrete time signal have the value at 0, at 1 it is having value -2, at 2 it is having 1, at 2 it is having 4, and at 3 at -1. Mathematically, we can represent the discrete time signal xn is equals to x small n t. These are the even and odd signals. In continuous time signal, the even signal is represented as x of -t is xt, and in discrete time signal, it is represented as x minus of n is equals to xn, which means that it is evenly folded signal. Odd signal where x of minus t is minus xt and x of minus n is minus of xn. It is the odd signal. Any signal can be expressed as xt is equals to even part of the signal plus the odd part of the signal, or x of minus t, that is your odd part of the signal, is represented as xet minus xot, where we can calculate the even part and the odd part of the signal by this given formula. Now, the third classification of the signal is periodic and non-periodic signal. In continuous signal, we have the condition that the signal, if it repeats and it follows the following formula, xt is equals to xt plus t, where then xt is a periodic signal, where t is the fundamental period time t naught, and where the frequency is represented as f naught is equal to 1 upon t naught. And this is the formula for angular frequency. In the term of discrete signal, we can also write as xn is equals to xn plus n, and then xn is the periodic with a minimum fundamental period, that is your n. F0, it is the number of fundamental period, that is 1 upon n naught cycles per samples. And if the unit of n is designated as dimensionless, then it is simply in radians. Now, the another classification as deterministic and random signals. Deterministic signals, there is no uncertainty with respect to its value at any time. Or we can say that any signal which can be represented by the mathematical formula is known as the deterministic, which means that its value can be determined. Random signals which are uncertain before it occurs, therefore their nature is random, and it cannot be represented by one mathematical formula, is known as the random signals. It is the determinant. If the signal is discrete time signal, then its energy and power calculated by these formula. Energy signals are those signals which have the finite energy and power can be zero, and it can be calculated by this formula. Capital E is equal to summation of minus infinity to plus infinity x square of n. And power signals are those signals which have the finite power and energy can be infinite, and its formula is limit n tends to infinite 1 upon 2n plus 1 summation of minus n to n x square n. So we can define as energy signals whose energy is finite, which means that it is greater than 0 or less than infinite. And power signals are those signals which has the value greater than 0 and less than infinite. Now, the basic operations which can be performed on the signals are amplitude scaling, addition, multiplication, differentiation, integration, time scaling, reflection, and it is a combination of various functions. Amplitude scaling, which means that we can scale the amplitude of the signal, where the C can be greater than 1 or less than 1. Addition, when the two signals can be additive in continuous time signal or as well as in the discrete time signal. Multiplication, when we multiply the amplitudes of the two signals, then it will represent the property of multiplication. When we differentiate the signal with respect to time t, then it is differentiation. And integration, which means that when we integrate the signal with respect to time, then it is known as integration. We can perform the scaling in both in amplitude as well as the time scaling. We can compress the signal or we can expand the signal in two forms of the time scaling. We can invert the signal, which is known as the time reversible, where it can be converted in even or odd signals. Then time shifting, when we shift the signal on the axis left side or the right side. When the signal is shifted to the right side, which means that the time has been delayed. Or when it is shifted to the left-hand side, it means that time is advanced. So this is the combination of various properties. Now we will discuss some basic elementary discrete time signals. One, it is the unit sample sequence, which means that the del n is 1 for only n is equals to 0, and it is 0 for n is not equals to 0. So we can say that it is an unit sample sequence which has the magnitude as 1 at time t is equal n is equals to 0, or else where its value is 0. So this is known as the impulse function. Second, we will discuss about the unit step signal. Unit step signal, which means that we have the amplitude of the signal is 1 at 0 and greater than 0. Otherwise, its value is 0 for n is less than 0. So it is an unit step signal. Now we'll discuss about the discrete time real exponential signal. A real exponential signal, which is defined at discrete instants of time, is called a discrete time real exponential signal or sequence. A discrete time real exponential sequence is defined as xn, that is equals to a to the power of n for all n. Depending upon the value of a discrete time real exponential signal may be the following type. When a is less than 1, the exponential sequence xn grows exponentially. And when its value lies between 0 and 1, the exponential signal xn decays exponentially. When a is less than 0, the exponential signal xn takes alternating signs. So this is the graphical representation where the value of a is greater than 1, which represents that the signal is exponentially increasing. In this, where the value of a lies between 0 and 1, it represents the exponential decay. And when its value lies less than 0, the exponential sequence takes alternating signs. Now the discrete time, a complex exponential sequence. A complex exponential signal, which is defined at discrete instants of time, is known as discrete time complex exponential. For mod of a is equals to 1, both the real and imaginary parts of complex exponential signals are sinusoidal. And for mod of a greater than 1, the amplitude of the sinusoidal sequence increases exponentially. And for mod of a less than 1, the amplitude of the sinusoidal sequence decays exponentially. So these are the different forms of the exponential complex exponential sequence, which has the value of mod a greater than 1 or less than 1. So today in this lecture we have discussed an overview of the signals, types of signal and their properties. Thank you.